All right, let's talk about bread. We're going to peel back the crust on something we eat all the time and find the incredible science that's baked right inside. Let's get into it. So, we've all seen bread like this, right? Some of it's dense, some of it is super light and airy, but have you ever really stopped and wondered what's making all those little air pockets? The things that give it that perfect fluffy texture? That is the big question, isn't it? What is the secret behind those bubbles? Because trust me, they are not there by accident. It's all part of a pretty amazing scientific process, and today we're going to solve that mystery together. Okay, our scientific investigation is officially underway. First up, let's look at the finished product itself, a perfect loaf of bread. I mean, it seems like magic. How does it get that lift? Yep, we're treating our kitchen like a crime lab today. Because baking really isn't just an art form. It is pure chemistry in action. And we're on the hunt for a tiny microscopic baker that's doing all the heavy lifting for us. Every good investigation needs a lineup of suspects, right? So let's take a look at the usual ingredients and see if we can figure out who's really responsible for this. Okay, here's our lineup: flour, water, sugar, and salt. Now, most of these are pretty straightforward. Flour gives the bread its structure, water holds it all together, salt's, well, salt's for flavor. But then there's yeast. That little packet, that's our prime suspect. And here is where it gets really interesting. This is our first huge clue. Yeast isn't just some random powder, it's actually a living thing, a tiny, single-celled fungus that's just sleeping in that little packet, waiting for the right moment to wake up. So, how do you wake it up? Well, it's actually super simple. You just have to give it two things. First, some food. It loves sugar. And second, a nice warm bath. Just some warm water. And when you mix those three together, that's when the chemical reaction kicks off. So we've got our suspect, but every detective needs hard evidence. We're going to set up a really simple experiment to catch this yeast in the act and prove, once and for all, that it's the one making the gas that creates those bubbles. Here's the plan. We mix our key ingredients, the yeast, the sugar, and the warm water, all together inside a bottle. Then, we just stretch a balloon right over the top. Why? Well, that balloon is going to trap any gas that our little yeast baker starts to produce. Okay, time for you to put on your scientist hat. Looking at this setup and knowing what we know about our suspect, what do you think is going to happen to that balloon? Go on, make a prediction. And if you predicted that the balloon would inflate, you are absolutely right. Look at that! The balloon just starts to fill up, all on its own. This is our proof. The yeast is definitely making a gas. And what's really cool is the more sugar you give it, the more gas it makes, and the bigger the balloon gets. So what is this mystery gas? Well, we've identified our culprit. It's carbon dioxide, or CO2. And this is the most important part. The yeast isn't just blowing bubbles. It's actually eating the sugar and creating a totally new material, this gas, as a byproduct. That's a true chemical reaction. Okay, so we know what the gas is. But to really get how it makes bread all fluffy, we need to understand a little bit about how gases actually behave. Which brings us to a class of wild particles. This is honestly the perfect way to think about it. Imagine that all those little gas particles are like a classroom full of super energetic kids. And the balloon, that's their playground. They don't just stand still, right? They run around, they bounce off the walls, and they spread out to fill every single inch of that playground. And you can really see the difference here when you compare the states of matter. In a solid, all the particles are locked in place. In a liquid, they can kind of slide past each other. But gases, their particles are just free, moving all over the place, filling whatever container you put them in. That's exactly why that CO2 gas filled up the whole balloon. So, just to recap what we know about a gas like CO2, it doesn't have its own shape or volume. Its particles just spread out everywhere. It's totally transparent, which is why we can't see it, and all of that crazy movement from the particles, well, that creates pressure. And that pressure is exactly what pushed on the inside of the balloon and made it inflate. All right, we've gathered our clues, we understand our suspect's behavior. Now it's time to bring all the science back into the kitchen and finally solve the great bread mystery. And here it is. This is the big aha moment. That inflating balloon is the perfect model for what happens inside bread dough. The yeast starts making those tiny bubbles of carbon dioxide, but instead of a balloon, they get trapped inside the stretchy dough, pushing it up and out from the inside. That is what makes bread rise. But there's one last super cool piece of science happening here, and that's the difference between a reversible and an irreversible change. See, a reversible change, like melting ice, is something you can undo. You can just freeze the water again. But baking bread? That's an irreversible chemical change. You can't unbake a loaf.
And that's the bottom line. Through this whole process, you've created brand new materials. The finished bread is chemically different from the flour and water and yeast you started with. You can't get those original ingredients back. That is some serious kitchen chemistry. So when you think about it, it's pretty amazing. From a tiny living organism making gas to an irreversible chemical reaction happening in your oven, the science behind a simple loaf of bread is just incredible. It makes you wonder, doesn't it? What other amazing science experiments are hiding in plain sight right there in your own kitchen?